Hello, everybody. We're going to start a new area of artificial intelligence today. What we're starting is the area of logic. There's other names we could use for it. We could use it automated theorem proving, but that sounds very mathematical. The idea is if we can translate a problem into logical statements, then we have an automated method for proving statements from that information. All the steps can be automated, and most of them are pretty easy. So that's the idea. And people thought this was a great idea. It looked like it could be universal. After all we had to do was translate things. And what they didn't catch right away is that the computer has no intuition. And so it tries to prove and go on and do everything. And we get that combinatorial explosion again that we get so often in artificial intelligence. But this has been used. In fact, it was used in one of the early programs. I believe it was for Shaky the Robot. And I'm going to show that at the end of this area, but not right now. Now I just want to get you used to it and get the terminology down. First of all, we are looking at what's called the first order logic. What that means is we are going to have some variables, and we're going to make statements about those variables. Now, the reason it's first order is because we're not going to make statements about statements. We're going to have a statement that would be something like X is a human. But we're not going to make statements about human, metaphysical statements about the property of human or something. So this is only this is a simple logic, I hope. Now, what do we have? We have a universe of objects, elements. We have to decide what our universe is before we start talking. We have the usual symbols. Let me see if I can get all of them out here. We have not. We have there exists, for all, and this one's hard to write. 2228 Alt X and 2227 Alt X. I had to find those by looking on the web because I could not locate them in the symbols that were in the word. We also have this symbol, and we have this symbol. And all of those have very well-defined meanings. And I'll start with some of the simple ones, but we will define propositions, predicates, I guess I would call them, predicates about elements in the universe. And usually I make my predicates capitals, and I make my elements in the universe lowercase. So here's an example. Man, Aristotle. Should be read as Aristotle is a man. Or I could say mortal X, which means X is immortal. X is mortal. So first of all, we have to have statements like that. They're called atoms. Either them or the negative of them are atoms, sort of the atomic building blocks of what we're going to do. Then we have to define all these possible areas, all these things we have here. So I'm going to define them. I'm going to give you a definition of 2227. Let's do the other one first. 2228. There. Now, that's all. We call this OR, of course. We have an intuition of what it means. The computer doesn't, and it doesn't care. It just needs a table to describe what it's supposed to do. So let A and B be items, let's say be filled in predicates, by which I mean they have something in them, that have a value T for true or F for false. Now, we aren't going to play around with the in-between things. We're not doing fuzzy logic. It exists, but we're not doing it in this. So, example would be A could be mortal X. Now the question is, how should you define the OR? The best way to do that is to make a table. So we have A, we have A, and we have B. And what we usually do is put down all possibilities. A could be T for true, and B could be T. A could be T, and B could be false. A could be false, and B could be T, and B could be false, and this could be false. That's every possibility. There's nothing left out there. We only have that number of possibilities. Then our table defines what we mean by the symbol we're playing with. I think it's this one. Yes, B. Our intuition works in this case. One of them's true, that's enough. One of them's true, that's enough. One of them's true, that's enough. And none of them are true. So that's a pretty easy one to define. It's also pretty easy to define the one that we call not. So this is just not, and I'll only put A in this case. And all that does is flip it. I don't have to put that line, I'll just put this line. So it just takes whatever the value is and turns it over. And that's read not A. Then the next one we want to look at is A. And now I have and B. This one might I think it's easy enough. A and B can only be true if everything's true. So we have to have both sides be true or else. No way around it. The one that sometimes gives people trouble is this next one. A implies B. That's read as implication. It means, another way of reading that is, if A, then B. So our job is to say, if I give you that A is such and such, and that B is such and such, is that legal? Is that can I reason that way? Well, if A is true and B is true, it seems to me that that's true. If A, then B. Then if we look at this one, if A is true and B is not, then our logic is really mixed up if we dare to say that that's a correct implication. We have A is true and B is not. That doesn't sound right. So we get rid of that one. Now here's the ones that start causing trouble. A person could start out with some bad conclusions and accidentally stumble upon the correct answer. So we could have, if no men are mortal, then Aristotle is mortal. Now, it doesn't seem right. We would say no men are mortal is false. We'd say Aristotle is mortal is true. But somebody could make it happen just by going along and making mistakes. Once you let a mistake in the system, anything can come from it. So we have to declare those to be true. I have one more I want to show you here. And the reason is, will become obvious in a minute. Not A, 7, wrong one. Or B. And you may ask yourself why, but you'll see. Well, it's an or, and B is true, so that's true. Well, let's see. A is true, so not A is false. B is true, but that doesn't matter. We already have a false. So, pardon me. Something's wrong there, pardon me. Not A is false, pardon me, and B is false, so that's got to be false. Now let's look at this one. F is false, not F is true, so that's true. And the same thing goes for here. Why did I do that? Take a look at the last two columns. They're identical, which means that we can get rid of the implications when we start proving theorems. And finally, I'll just make this observation. A implies B is read A if and only if B, and is the same as A implies B and Now, B implies A. So again, make sure you understand this is AND. I better put these above it. This is OR. This is A or B. This is not A. This one is A and B. This one is if A, then B. And this one is the same as, it's read is A if and only if B. And it's the same as that. Now there are two more things to explain. The for all. For all X is read for all, I guess I'll put it in quotes, for all X. It is the universal quantifier. And it means, well, so for an example, for all X, model X, in case you're wondering, I just fed her. I was hoping that she'd be quiet for the presentation, but she doesn't seem to want to be. This is read as all X are mortal. That's one way of reading it. You could read it as for all X, X is mortal. The other quantifier is called the existential quantifier. Existential X, say mortal X, is read as there exist at least one X that is mortal. Doesn't tell me they all are. It doesn't tell me which one it is. It just says there's at least one in your universe. Now that's what we have. That's the whole idea. I'm going to put together, well, the question now is, how can we use these? I'm going to be using an example that I got from the web, and I'm going to bring that up right now, and I'm going to try to copy parts of it, and then we'll see what we can do with it. So give me a second to write it, get it all. Here it is. So I'm going to put down, pardon me, it's going to take me a minute to get it. I'll give you the website when I tell you this. All right, here's what it's going to be. It's going to be this part right here. So I'll bring that over to here. Well, so much for copying. I can work it out though. First, I'm just going to make this larger. Excuse me, I lost my mouse. Now let me just get this for you. I'm going to make this larger. And then I'm going to split it into its pieces. So here are the pieces that we have. Marcus was a man. Marcus was a Roman. All men are people. Caesar was a ruler. All Romans were either loyal to Caesar or hated him, or both. Everyone is loyal to someone, and people, people only try to assassinate rulers that are not loyal. They are not loyal to. And finally, Marcus tried to assassinate Caesar. Now, the question we're going to ask, our question is, who hates Caesar? That's what we're going to see if we can come up with. This isn't entirely a normal approach, but it's a good approach. The first step we have to do, step one, is to translate into logical expressions. Most of these are easy, but a few might give us a little headache here and there. English is so much more expressive than the logic that you get all kinds of, you have to really play around to make sure you got it right. What I'm going to do is I'm going to take these, I'm going to bring them down again, so I'll have them, and then I'm going to try to translate each one of them in place here. First of all, we might want to ask, what is our universe? It looks to me like a universe is people. I take that line that all men are people to mean that there are other people who aren't men, particularly women, for example. So Marcus was a man. Now I have to decide, how am I going to represent things? So I'm going to say man X means X is a man. I probably won't write that kind of thing all the way down. I am going to have Roman. I'm going to have people. I'm going to have ruler. I'm going to have loyal. Now I got to be careful. Loyal to somebody. So I'm going to say loyal XY means that X is loyal to Y. I hope that's the way what I was looking at does it. If it isn't, well, I'm going to have it different. And finally, hate means, hate XY means X hates Y. And I guess I have to have one more. Try assassinate will be the last X. Y means X tried to assassinate Y. So I'm now going to use that to fill in all these lines. Marcus was a man. I can write as follows. Man Marcus. That's a simple way. That's all I have to say. Marcus was a Roman. I just translate it as Roman Marcus. All men are people. Well, that would translate into a universal statement. It would go as follows. For all X, if man X, then people X. It says it's true for everybody. Ruler Caesar is the translation of that line. Now we got to be careful of this one. All Romans were. Well, I'm telling you something about all Romans. So I'm saying for all X. If X is a Roman, what do I know about them? Well, let's see. What do I know about them? I know that they are loyal to Caesar. So that means that I have a possibility of loyal X to Caesar. Make sure I get it in the right order. I said that XY means X is loyal to Y. So they're either loyal to Caesar or that's the wrong one. Or they hated him. Well, that's hate. And it says X hates Y. So it's X, Y, Caesar. So that's been translated. I put the parentheses in just to make sure you saw what is where. Everyone is loyal to someone. This is another one that's a very different, you got to be careful at translating. This one says something about everyone. So I'm going to translate it with a for all. I'm going to say for all X. Now here's the problem. I can't say everybody is loyal to someone. All I can say is that if you give me an X, I can find a Y such that everyone is loyal. So loyal X to Y. The important thing is to notice here is that Y can only be found after you give me X. I'm saying everybody is loyal to someone. Well, that means if you give me X, I'll find somebody they're loyal to. But I can't do it for everybody. I'm not saying that there's a person that everybody's loyal to. Now, let's see the next one. People only try to assassinate rulers that are not loyal to them. So, for all X, if we have a people X, then that implies, but wait a minute, I want to change that. No, people, if a person is a people and I may never get that right. And they try to assassinate somebody. So they try assassinate I gotta be careful. For all X and for all Y. If somebody is a person and X tries to assassinate Y, then those two things together tell me that the only possibility is they're not loyal to. So it says the people who assassinate are not loyal. So it says they are not loyal. So it means X is the person who's doing the assassination, and Y is who they're assassinating. So that is the way it is. Now that's a little more complicated statement. We are going to have to make sure we understand that. And this one just says, try assassinate Marcus Caesar. And I just go up here and take this. All right, I got it. I'll get it back. All right, I'm almost there. Yeah, there it is. So I just get rid of this. Maybe I should stop while I'm ahead. All right. That goes immediately. They're all together in one line. So I guess I'm just going to have to see if I can delete it. Nope, I can't delete it that way. We'll just leave it there. Not even worry about it. So what we basically got is a set of propositions now. So what I'm going to try to do now is copy what I have here. I'm going to copy it once more. I'm going to put it down here because I'm now going to start the next step. Now with this, let's see if there's any chance that I can, yes, finally. That goes. I don't need to put that there anymore. And this goes. And this goes. And this one. And we got it. Now, step 2. We want to move the quantifiers to the front to make a pre-next normal form. That's just a fancy way of saying put all the quantifiers in the front. That one's okay. That one's okay. I don't think we have any to worry about. All our quantifiers are in the front. So no changes. And then drop them. Drop universals and fill in existentials. I'll show you what I mean by that right now. There's no reason to carry around for all x. This is true for any x in the business. There's no reason to carry around for all x here. This one, for all x, for all y, again, we can just drop it. So we don't have to do any existentials. I thought we had one. I hope I didn't lose it somewhere. I thought I had it there. It exists somewhere up here. Everyone is loyal to someone. That's the one. Yes, I did have that one. That's F. And let's see, okay, that one has to be rebuilt. I got that, that one, I should not have translated the way I did here. I lost something. Now, this is the first one where we have to worry about the y. Y is not universal. So what we have to do is replace it with something like this. What that says is that the second item is a function of the first item. So we've gotten rid of the quantifiers. Next step. And realize that's very easy for a computer to do. None of this has been hard yet. So step 3, remove implication and double implication. So we don't want them anymore. We want to get rid of them. So now we look and see what we have. And we're going to use what we had very far back here. Get rid of that and put step 3 here. Remove implication and double implication. I'm going to use the table right here. Anytime I have an implication, I'm just going to make it not A or B. If I have a double implication, I'm first going to change it into this and then apply that. So all I have is not A or B. So let's see what we have. Where do we have implications? Now we have one here. That says change this to an OR. And make this a not. So that takes care of that. Then this one. Use a not in front and change this to an OR. And we got one more here. So this one might give us a little trouble. We have a not, and we have the OR. Now the question is, are we done? Well, we got rid of all those. Fantastic. One step done. Step 4, which I'll probably do on another page. Step 4. Move all negatives so that they are directly in front of a proposition, of a predicate. We want only atoms and negative atoms. That's what we're saying. We want to get everything down to basics. So again, I'm going to take this, put it here. And now, do I have any to worry about? This one right here. Well, let's see. No, that's no problem. It's right in front of the Roman X. That parenthesis shouldn't even be there. It's a waste of time. So we don't need it. This is the one that's a problem. Not this or that. If we were in class, I'd say, does anybody have any idea how to do this? And you'd probably sit there and wonder what language I'm talking. But I think you do know, even if you don't want to think about it right now, I think you know, because you do it in computer when you're writing programs. Not and end is the or of the knots, and not and or is the end of the knots. So all I do is take the not inside to both of them, and I change this to the or. And now I am there. What I have is the result of this is called conjunctive normal form. What it means is that we are looking at a group of conjunctions. That is the ors, and everything else is either an atom or not an atom. So we've broken it down into basic little pieces. Now we're ready to begin the proof. Now I want to make sure I get it exactly the way they do it. I don't want to get into any problems here. You can see this, of course, so I'm not pretending. Just that's if you want to look at how he does it. I got this from a source at another college. You can see they spend more time playing games making it. Here's what we want. So I'm going to go this way. Who hated Caesar? So who hated Caesar? Now what I want to know is, I want an X such that hate X Caesar. That's what I want. Now, the person who wrote this had a slightly a different way of putting it. He adds to this the and, puts a period between them. He adds answer X. The comma is a way of saying and. It's more complicated if I put the and in. What I'm really saying is I have two pieces here, and I may refer to them as 5A, A part and B part. So that's the first thing you do. But now there's an interesting little quirk. The only way we can do the proof is by a resolution method. We use a proof technique called resolution. And it's based on something you should know about. You should have got it somewhere. I wonder if I should cheat. I'm just going to call it method. I can spell method. What really is using proof by contradiction. One of the best known proof techniques in the world. You should have seen it in a math class, in Math 117, somewhere. what we do is we introduce the negative of what we want to prove into our list of true items, which, by the way, is called a database. Knowledge base is the word they use. Knowledge base, or KB. And try to reach an empty clause. A contradiction is what it will be, but you'll see how that works. Now, the proposition, I'm going to not worry about the answer. I don't want to negate that. What I want to do is I want to add the negative of who killed Caesar. So I guess I better get to a new line. I'm going to add I. And I is going to be not hate X Caesar. I want to make sure that I put that exactly the way it is. Yes, this is. I probably should have called that, put a there in there. I left that out. I'm sorry. There exists an X, such that this is true. So I should have. Well, it's there. So I'm going to put in that now. Now there exists an X, such as Caesar, and answer X. Well, the negative goes in now. Negative. And what I had up here, Control C, bring that down here, Control V. I think I will make this N now. It's easier that way. It doesn't matter. I think I'll just leave it the way it is. And remember, I had a there exists there that I dropped out accidentally. There exists an X. Now, there's a very normal way of doing things here. It says, if you have not there exist, then that's the same as for all X not. After all, if I say no men are mortal, then that's equivalent to saying all men are not mortal. So I move that by there. I now have a for all X, which I remove, and I have my not hate X Caesar. And I'm not going to negate the other part because that's what I'm trying to prove. So I'm just leaving that out, making that just a second part of this. I think I'll check and see, make sure that I'm doing it the way my source is doing it. Because I never put the answer in before when I did it. Yeah, he's just negating that part. That's what I thought he did. All right, so, and we have also the answer X. So we find that there, that's what we're going to do. And they're both true, so we can put an and in front of them if we want to, or an or. So now the question is, how do we do this? We use what's called a clash. Two clauses, two lines in the database above in the knowledge base. Clash. If there is a in one and not A in the other. If this is true, then we can unite the two clauses and remove the A and not A. Now that may take a little thinking here. But for example, not hate X Caesar. Do I have a hate X Caesar? Yes. So I'm going to say, I'm taking this, I'll call this J. I'm taking E and I. I didn't realize that would happen. E and I to get. Now I take everything else. So all of this I take. Don't see. I take that. And if there were anything in the other side, I would take it too. Now, does that work? Let's see. Well, we have not hate X, not hate Caesar. But this line is supposed to be true. E is supposed to be true. So the only possibility is that the first part's true. So that's why I can do it. So there's my first clash. And now the next question is, can I get any more that work like that? Well, let's see. Do I have a not loyal here. Let's look at F and G. They both have they have a loyal and a not loyal. So I should be able to take just this part here. And I get that. Now, if I wanted to be very, very, do it like a computer, in other words, I would go one by one all the way down, but I don't feel like doing it. All right, now what? This part wasn't supposed to be there. So again, notice what I did. I got rid of not loyal and loyal. Since loyal is true, I can say the rest of this is true. Just got rid of them. All right. My object is to keep getting smaller and smaller things until I get them down to nothing. Well, let's see. So far, I haven't had to make any substitutions. But let's see if I can make one. I have Roman X here, and I have Roman Marcus here. So what I'm going to do now is I'm going to say KL. I'm going to take B, and E, and substitute Marcus for X. Now I can do that because X is universally quantified. So I can put anything in I want. Well, Roman Marcus will mean that I get rid of everything but this here. I'll take that down. And I just put it in and then take out the piece that I had in the front that I couldn't play with. So I've got a little lower. Well, let's see. What else do I have that I might be able to get rid of? Well, it's interesting here. I have hate. Oh, I didn't make the substitution. Pardon me. I was supposed to make the substitution here and here. And now that's really going to help, because I have not hate X Caesar, and there's no reason why I can't make a substitution there. So I'm going to say M. I'm going to use I and L to get, I'm substituting for X Marcus to get loyal Marcus Caesar. So I got that. I'm almost there. You see the line that has try, assassinate, and loyal. I'm going to do it this way. I'm going to take, for N, I'm going to take the line that I just had, which is N, and I'm going to also take the line G, and I'm going to get, well, let's see, the line N is going to wipe out the loyal, and I got loyal Marcus Caesar, so I'm going to go up here, replace X with Marcus, substitute Marcus for X, and Caesar for Y to get. Let's take, I'm working with G. Let's take G down. Now, I had loyal here, so I can get rid of this part. And I think I have an extra parentheses. Okay. And I had to make the substitutions, which I didn't do. This is Marcus. And this is Marcus Caesar. Well, I think I'm seeing something happening here. I got try assassinate Marcus Caesar here. So why don't I try the following? O says take the line I just met, N, and the line H to get, and I'm only going to have one thing left, not people Marcus. Have not people Marcus. Now let's go up here. Marcus is a man. Look at A and B. I'm going to take A and B. This is P. A and B. Substitute Marcus for X to get, okay, A and B. A is man, it was A and C, pardon me. A is man, and so I get people, it's A and C, to get people, Marcus. And finally, PQ, O and P can't both be true. So we have a contradiction. Because flashing them gives us an empty clause, an empty statement. Now, I used intuition in a few places there. The machine doesn't have it. So it might have generated many more statements than I generated here. But we came up with a proof. And if we give the computer enough time, if the statement is true that we're trying to prove, then it should come up with a proof. However, if we try to prove something that isn't there, isn't true, the computer may never finish. And so we might say, well, we're going to try to prove the positive and the negative of something in two separate proofs. But the incomplete theorem says it's possible that neither of them can be proved in our knowledge base. So there's problems, but that's basically the whole thing. The next steps, I mean, this is the whole simple thing. The next steps would be, how do you speed it up? What strategies do you need? How do you pick what you're going to class? And there's a lot of different approaches for that. But that's what I want to say so far. I'm going to give you a problem to do with this. It won't be to write the code. It'll just be to do what I just did here. I don't quite have it ready yet, but I'll probably have it by midnight or so. But I'll put this out right now. So see you later.